Great, thanks, Pavina. Okay, yeah, thank you very much. I'm Rick Pardoe, co-founder and lead engineer at Liquidity. And yeah, today I'll talk about some research findings into DeFi oracles. So Liquidity is launching a new system. The working title is bold. The intent is to really kind of break the stablecoin trilemma and create something that's more scalable than LUSD, our previous stablecoin. It's an immutable system, and it's going to be as decentralized as possible, and we'll get into that a bit later. It uses a single state-ETH collateral reserve, and it mints stablecoins from that reserve. It also has leveraged state-ETH positions and a borrowing component as well. And crucially, it requires a state-ETH USD price oracle serving the latest market price. So yeah, we had a few research questions around oracles. So firstly, which one should we use? The space has moved on quite a bit since we launched Liquidity V1 2 years ago. Front running is probably going to be important for us because we have these leverage positions which are vulnerable to front running. And so some way to mitigate front running is going to be key. And then finally, like, how should we actually design the price feed logic? Do we need a fallback oracle? Because Liquidity, the new system will be immutable. So if the oracle fails or freezes, we need some kind of on-chain contingency or maybe like a circuit breaker. So there's sort of three kind of primary types of price oracle. There's the status quo, which is this push-based approach, which Chainlink use. You're probably familiar with it. They just push prices on-chain with some minimum frequency, and you can just read them. And it's super simple to integrate into your system. It has like very simple developer UX. The downside is it can be somewhat laggy prices sometimes. There's this new generation of low latency oracles now. They take a pool-based approach where the user or keeper actually pulls the price into the system. So Pith, Redstone, and Chainlink's new low latency go with this approach. The downside is they can be more complex in terms of the front end, and also the composability can be reduced. And then finally, there's kind of DEX TWAPs, so you can simply read or calculate the on-chain time-weighted average price from like a Uniswap pool. So we had a few criteria we looked at, and I'll run through a couple of them. So admin control and immutability, like who controls the oracle, when can they change it, how can they upgrade it, what's the scope of the upgrades that they can do, or is it in fact actually immutable? And then compatibility, so our system will be immutable, and how do we kind of ensure that the oracle we're connected with is going to last forever, or like not change their address or their interface, because we can't point our system to a new oracle, so we need kind of guarantees from them. Latency, low latency is important for us, as I mentioned, with these leverage positions, which can be vulnerable to front running. And yeah, also the oracle track record. How long have they been live for? What bugs, if any, have they had? And how battle tested is it? And then obviously like the usual kind of oracle properties, crypto economic guarantees, attack costs, trust assumptions, the state of the nodes, and whether they're actually on mainnet, which is where we'll launch. So here's like an oracle comparison table. Hopefully you can read this. So green is like good, yellow is acceptable, orange is concerning. And yeah, you can kind of see that no oracle is perfect. They all have trade-offs. Two we really like, just for their decentralization and immutability, are Telor and like a Uniswap TWAP. But actually, both of them are not good fits for this new system for different reasons. So Telor we used in Liquidity V1. It's immutable now. It wasn't previously, but yeah, it is now. And yeah, fully decentralized, but it just has a very laggy price. So it's like the price needs to go through a dispute period of something like 10 to 20 minutes to be able to be kind of confirmed as legitimate, and that wouldn't work for our new system. Uniswap TWAP actually also has a lag, but the main problem with it is it doesn't have any liquidity guarantees. So when V4 launches, liquidity can migrate from V3 to V4, and the attack costs come way down, which would be no good, as we can't point our system to a new oracle. So then there's these kind of three low latency oracles, Pith, Chainlink, Redstone. They all offer, well, they advertise like sub-second low latency. So it seems good, and I guess like the shortcoming of all of them is they're not perfectly decentralized. You can kind of see like they all whitelist their nodes. They all have some admin control currently. There are plans. There's talk of like moving to token governance at some point in the future, but it's unclear whether that governance will really kind of fully govern the whole tech stack in a decentralized way. So if we're choosing between them, it kind of comes down to track record. And currently, Chainlink clearly have the best track record there, just in terms of battle testedness and being live for like 5 years with few issues and good quality control. So Chainlink probably has the edge, but we're open to other solutions there. So just to go into Frontrunning now, where is it a problem in our new system, which is working title is bold. So we have these leverage operations where that's where Frontrunning is kind of worst in our system. So just for an example, let's consider like ETH price updates that get sandwiched by operations. And a user could open a position as a front run to an ETH price rise, close the leverage position, and then extract a leverage gain. Conversely, if they already have a position open, they could close it as a front run to an ETH price drop, then reopen it and evade a leverage loss. And yes, these gains are actually leveraged, so they're amplified. So the gains or the loss evasion is greater than it would be without the leverage. Similar with stablecoin operations, you can use mints and redeems to sandwich Oracle updates, but they're not as bad because the gains aren't leveraged. So there's a couple of easy wins with Frontrunning. We can implement a minimum delay between opening and closing, which introduces kind of price uncertainty for the attacker. So then it becomes non-risk free. They don't know what price they're really sandwiching or what it's going to be when they're able to close their position. So yeah, it kind of makes it unattractive. It's effective, but only in one direction. So it doesn't stop them evading a leverage loss because they could close their position as a front run to an ETH price drop, immediately reopen from a different account, and they could then still evade the leverage loss. One thing we can do, another easy win, is just pause the system in high volatility periods. So synthetics actually do this, and because front-running opportunities are kind of power law distributed, the worst front-run opportunities happen in high volatility. So you just say, okay, let's pause the system in extreme volatility, and only a few seconds per week actually prevents the worst front runs. We'd only do this when the system is healthy, though, because we actually need those positions to be opened when it's unhealthy. There's also this worst price approach where synthetics actually pioneered this one as well. And yeah, I'd really encourage you to check out their blog post, History of Front Running, which covers a bunch of these approaches. So with this approach, you have two Oracle prices, a current price and a lagged price. And you take the worst one for each user operation. So you'd open a position using the maximum price and close positions with the minimum price. And that creates a kind of sort of effective fee. And that reduces front-runner profits. And the fee is nice because it ends up being proportional to volatility. So here we see kind of an ETH price regime where it's low volatility for the first half and then flips to high volatility. The yellow line is the delta between the ETH price and a lagged ETH price for some constant lag. And that you can see the delta increases in high volatility. So it's nice that we get this sort of effective fee proportional to volatility. Which is good because front-running profits are proportional to volatility as well. Then there's low latency oracles. I won't go into the architecture of these. I think other people will cover them later probably. But there's kind of two main approaches. There's a sort of self-serve where the user pulls the price, and delayed settlement where a keeper pulls the price. And the self-serve has relatively low latency. The delayed settlement approach actually completely mitigates front-running because it introduces a delay between the user committing to transact and the keeper actually finalizing it. But yeah, the downside is it reduces composability because you have need two transactions there. So yeah, that's our front-running solutions. And then we looked at potential contingencies. So what happens if the oracle fails or freezes? As I said, we can't step in and do anything with governance or an upgrade, so we need the system to kind of handle things automatically. And this is a kind of a lesson learned from our Liquidity v1. Complexity is bad. We already knew it, but we relearned it with V1. So basically, this is the kind of state machine we built for our Oracle logic, and it's like quite complicated. There's these kind of conditional state changes, and we focused a lot on getting this logic right. So with a primary Oracle and switching to a fallback under different conditions and trying to switch back. And we focused a lot on this, and our audit for the Oracle was basically pretty much purely on this. And we actually kind of didn't spend enough time just on the basic integration. And we actually had a bug in Liquidity's fallback Oracle usage. So we used Telor as our fallback, and we incorrectly pulled the current price from Telor when we should have been pulling a lagged price for Telor to give us a price we could be confident that was accurate. And so this is the code for that in our system. You can see we're getting the count, which is like just the number of data points on the Telor feed. We're getting the current time by using essentially the current count. Then we're getting the current value and using the current time, but we shouldn't be using the current value. So we couldn't fix this because Liquidity is immutable. Thankfully, Telor actually able to implement a fix for us, like just before they themselves went immutable. So they kind of solved this. And just to note that, like, Liquidity had never switched from the primary to the fallback, so it was always using the primary Oracle. But had it ever switched to this using the fallback, then if the primary had failed, then we would have been vulnerable. So this is the fix Telor put in for us. Basically, it's saying if request ID is 1, which is the ETHUSD feed, then serve us a price that is at least 15 minutes old, which allows it to have gone through this dispute period, and we can be confident that it's an honest price or an accurate price. So yeah, the lesson is just favor simplicity with kind of fallback and contingency design. If we go with a fallback, it would be very simple logic, something like if the primary fails or freezes, fallback once and don't return. With simple conditions for a fallback, like if it's frozen for half a day or the data is just bad. We can only protect against some technical failures, not manipulation, because people can always look at your particular conditions and sort of play within those boundaries to sort of fly under the radar and not trigger your fallback. So it's really only useful for detecting some technical failures. There's a question of what signals can we actually use in a pool-based Oracle, because with these low latency approaches, you basically just pull a blob of data on chain and then verify it with the Oracle's verifier contract. It's hard to see how you would then detect if the Oracle's actually failed, because if it reverts, it could be reverting because the data's bad rather than the Oracle's broken. So that's a real challenge, and something we want to think about more. Circuit breakers. So Gyroscope have a really cool circuit breaker design. It's really sophisticated, and I think they'll be speaking about it tomorrow. So basically, they use Chainlink as the primary. Then they pause their mints or redeems if any of these conditions is met. So if the Chainlink price jumps too much, if it deviates too far from a median of signed prices and TWAPs, or if they actually detect anomalous asset flows, like too much collateral moving in or out of the system. The problem for us is if we pause operations in our system, then what can we do? Because Gyroscope have governance, so somebody can actually step in and say, okay, there's something wrong with the Oracle, let's reassess, pause the system, and set a new Oracle. We can't do that. So there's no human intervention possible. So complex circuit breakers for us probably are not the way forward. Thank you very much. These questions are all still open, and we're still considering everything. So if you have an Oracle solution or a design idea, please share it to us. Thanks a lot.